The development of humanoid robotics has reached a new level with the launch of Optimus Gen 3, Tesla's advanced robot. Far from being just a futuristic project, this new version is already consolidating itself as one of Elon Musk's company's most daring and concrete initiatives. Since its first iteration, Optimus has undergone significant transformations. Now in its third generation, the robot has received notable improvements that place it in a prominent position within the artificial intelligence and automation landscape. One of the most impressive aspects is its ability to learn. Unlike traditional robots, which operate following pre-programmed instructions, Optimus is trained using reinforcement learning, honing its skills through trial and error, a process similar to human learning. This learning method allows the robot to develop complex movements, adapting to unexpected situations and chaotic environments. This represents a significant advancement for robotics with commercial applications. Tesla leverages a massive database of data from its autonomous driving systems, more than 1.2 billion miles driven, to feed Optimus's artificial intelligence. This real-world data is converted into cognitive experiences, accelerating its learning. Using real traffic information to train a bipedal robot may seem unusual, but it's a logical approach. Instead of relying on artificial simulations, the robot learns from concrete and diverse real-world situations. Visually, Optimus impresses with its slender frame and upright posture, coming closer to human appearance than other robots on the market, such as Boston Dynamics Atlas. Among the Gen 3's most notable advancements is its ability to walk with extended knees. This type of locomotion not only provides a more natural gait, but also requires sophisticated engineering to maintain balance and stability. Although this detail may seem merely aesthetic, it has significant functional implications. It allows the robot to move more fluidly in spaces designed for people, such as homes, offices, and healthcare facilities. Optimus has also evolved considerably when it comes to object manipulation. His hands feature 22 degrees of freedom, with independent joints that enable extremely precise and coordinated movements. This manual dexterity allows the robot to interact with objects in a human-like manner. Tasks previously considered unfeasible for machines are now within its reach. A striking example was seen in tests where the robot managed to grab moving balls, a feat that requires visual perception, motor coordination, and anticipation. Furthermore, Optimus is energy independent. It can detect when it needs to recharge, locate its charging station, and connect to it automatically. This autonomy eliminates the need for constant intervention by human operators, which increases its potential for use in prolonged tasks and in remote or dangerous locations. For a company like Tesla, which values operational efficiency, this feature is crucial. It allows robots to operate continuously, 24 hours a day, without relying on constant supervision from technicians. In terms of production, Tesla has already begun mass production of Optimus at its Fremont facility, demonstrating that the robot has gone from being an experimental prototype to a product at an advanced stage of commercialization. The goal is ambitious: to manufacture around 12,000 units by the end of 2025. To achieve this, the company has intensified its hiring process, seeking engineers, data scientists, and software and hardware specialists. These moves reinforce that Tesla is taking robotics seriously, aiming to create a new business division with potential similar to that of its automotive sector. Elon Musk's vision goes beyond replacing assembly line workers. He plans to build a robotic workforce capable of working in various sectors of society. Planned application areas include elderly care, home security, and urban service provision. The goal is to develop a truly versatile and adaptable robot. Transitioning from an industrial robot to a personal assistant is no easy task, but Tesla appears to be laying the right foundation: refined hardware, powerful artificial intelligence, and the ability to operate autonomously. While experts warn that widespread adoption may take time, especially in sectors that require empathy and ethical judgment, the potential for automation is undeniable. Institutions like Morgan Stanley see Optimus as a game changer. Analysts project that the humanoid robotics market could reach up to $30 trillion in the coming decades. The arrival of humanoid robots like Optimus could spark a true revolution in the global economy, restructuring entire sectors by replacing roles traditionally performed by millions of human workers. If this transition is handled responsibly, the productivity gains can be immense, allowing people to focus on more creative, strategic, and analytical activities. However, the obstacles aren't just technological. Ethical, social, and legal issues are still far from definitively resolved. Topics such as civil liability, privacy, and digital security require extensive debate by experts and society at large. Tesla claims to be committed to ethical principles in the development of artificial intelligence, but so far little is known about the specific security protocols applied to Optimus. Despite this, the enthusiasm surrounding the project is evident. With each new presentation or video released by Elon Musk and his team, the tech community follows closely, curious to see what's next. Many are already comparing Optimus to the iPhone of robotics, with the hope that Tesla will be able to replicate Apple's feat of transforming a niche product into a mass consumer phenomenon. But the path to get there is far from straightforward. Companies like Boston Dynamics, Figure AI, and several startups are rapidly advancing their own versions of humanoid robots. What sets Tesla apart is its integrated approach. It combines advanced artificial intelligence, in-house hardware, mass production, and a massive database of real-world data, all within the same company. Furthermore, Tesla's culture favors rapid innovation, with short testing and validation cycles, which ensures a pace of evolution that is difficult for competitors to match. Internal tests have already shown that the robot is capable of performing tasks such as folding clothes, assembling small components, carrying boxes, and even dancing with synchronized movements. As simple as these actions may seem, they involve a high level of technical complexity, requiring refined motor control, precise perception, and the coordinated functioning of several systems at the same time. Elon Musk believes that, in the future, robots like Optimus will be present in practically every home, just as we have refrigerators or voice assistants like Alexa today. This futuristic vision still generates skepticism in some quarters, but few doubt Tesla's ability to turn ambitious ideas into reality, especially considering its track record with electric cars and battery solutions. What once seemed like pure science fiction is now beginning to materialize in real laboratories. Optimus Gen 3 is no longer just a promise, it's a concrete glimpse of what's to come. At the current pace of development, the robot could soon take on roles that seem unimaginable today, from medical assistants and tour guides to firefighter assistants and private tutors. Each new advance in this area represents not only a technological achievement, but also a cultural milestone which redefines our relationship with machines. The presence of robots with human appearance and behavior raises questions about how people will adapt psychologically to this new reality. After all, living with a machine that walks, talks, and learns like a human being challenges the traditional perception of what life is. Social acceptance of Optimus will undoubtedly be one of Tesla's biggest challenges. Even with cutting-edge technology, gaining public trust can be more difficult than overcoming technical limitations. To address this obstacle, the company has been focusing on a more user-friendly design. The robot's appearance is clean, sleek, and conveys a certain friendliness, avoiding aggressive or overly mechanical features. This aesthetic care makes the robot more pleasing to both consumers and investors, as appearance directly influences the feeling of safety and perceived usefulness. Another important aspect Tesla has been developing is natural interaction between humans and robots. Optimus is being trained to recognize facial expressions, voice commands, and simple gestures. With this, the human-machine interface is no longer based solely on buttons or screens, and begins to resemble a fluid conversation, like the ones we have with other people. The ability to control the robot using natural language, with commands like, "Pick up that box," could significantly accelerate its acceptance into everyday life. Additionally, Tesla is testing Optimus in a variety of practical scenarios, from offices to hospitals and even the field, to identify where it can make the biggest immediate impact. The current testing phase plays a crucial role in refining the algorithms that guide Optimus's decisions and adaptations. Each new environment tested presents specific challenges that strengthen the robot's performance and increase its reliability. Behind the scenes, Tesla also invests in real-time digital simulations. In these virtual platforms, Optimus can experience millions of interactions before ever executing any action in the physical world. This process not only saves time and reduces risk, but also accelerates learning, making the robot increasingly efficient with each new software update. The robot is equipped with a highly advanced sensory system consisting of cameras, gyroscopes, accelerometers, and tactile sensors. This sensory body allows Optimus to have spatial perception comparable to that of a human, even in dark environments or with various obstacles. Another notable feature is its balance. The robot can remain upright even when pushed or walking over uneven terrain. This stability is essential for operations outside the controlled factory environment, such as in homes or outdoor areas. In addition to mobility and object manipulation, Tesla is also developing a voice system for Optimus. The idea is for the robot to communicate naturally, with simulated intonations and emotions, something that could facilitate its interaction with children, the elderly, or people in vulnerable situations. These details show that the project goes beyond the technical aspect. The company also considers the psychological and emotional impact a robot can have on people's lives. There are even rumors that a smaller, more affordable version of Optimus geared toward light household tasks, possibly called the Optimus Mini, is in development. This would open the door to residential users who don't yet have the need or budget for an industrial-grade robot. The artificial brain that controls Optimus is constantly evolving. Just like in Tesla vehicles, the data generated by each robot is sent to central servers, creating a collective learning system. In practice, this means that if an Optimus in Tokyo learns to climb narrow stairs, that knowledge can be automatically shared with all other connected robots, anywhere in the world. This concept of collaborative learning, almost like a global mind, exponentially accelerates the development of the robotic species. Another important differentiator is the remote update system, the same one used in the brand's cars. This ensures the robot is always running the latest software version, without the need for a return trip to the factory. This continuous evolution model is one of Tesla's greatest strengths, as it allows the robot to improve over time, similar to human development. In the job market, the effects of this technology are already beginning to be felt. On assembly lines, for example, Optimus is already capable of replacing humans in repetitive or high-risk tasks. But Elon Musk goes further. He envisions robots caring for the elderly, providing relief in natural disasters, or even accompanying children in supervised educational activities. These applications, though seemingly distant, are already being tested at Tesla's research centers. The idea is to transform Optimus into a true personal assistant, not just an automated tool. As a result, new careers are also beginning to emerge, such as AI trainers, robotics maintenance technicians, and even psychologists specializing in human-machine interaction. The future of work will not only be impacted by the replacement of roles, but also by the creation of new opportunities as technology evolves. Tesla, aware of this, already offers internal training to enable professionals to operate, program, and maintain these robots. Another point of concern is cybersecurity. Because the robot is highly connected, protecting its data and preventing hacks becomes a priority. After all, a robot with access to homes or hospitals needs extremely robust defense mechanisms to prevent any type of malicious use. The company also needs to deal with government regulations, which are still in their infancy when it comes to autonomous robotics. Specific laws will need to be created or adapted to accommodate this advancement. Countries such as Japan, Germany, and South Korea have already expressed interest in receiving Optimus test units, especially due to the shortage of skilled labor in critical sectors. As the global population ages, there's a growing need for solutions that support seniors at home, in hospitals, or in public services. Optimus, with its mobility, physical strength, and ability to understand verbal commands, seems ideal for this type of need. Even so, there's still uncertainty about the robot's final price. Musk has already stated that it will be cheaper than a car, but that scenario is still far from reality. With the standardization of production and increased manufacturing scale, costs may fall in the coming years. For now, access should be restricted to large companies or institutions. Still, Tesla demonstrates a full commitment to making the Optimus more accessible, following the same logic applied to the brand's electric vehicles. Strategic partnerships with chip suppliers, research centers, and other technology companies reinforce that the project has solid foundations and is not just a passing experiment. Each new version of the robot shows clear advances in intelligence, fluidity of movement, and adaptability. As the world watches closely, A quiet revolution is unfolding. The gradual integration of intelligent robots into people's daily lives. The path taken by Optimus Gen 3 represents more than just the progress of a machine. It is the beginning of a new era, where the line between what is human and what is artificial begins to blur. Tesla is turning science fiction into reality. And despite the technical, ethical, and social challenges that still need to be addressed, the results achieved so far are impressive. We are witnessing the birth of a technology capable of reshaping not only industries, but also homes, hospitals, schools, and the way we understand work, care, and coexistence. Optimus's impact goes far beyond productivity. It forces us to reflect on the future of humanity and the role robots will play in our lives. And the truth is, this future is arriving faster than we imagined. If you want to keep up with all the latest news about Optimus, Tesla, advances in robotics, and other technological innovations shaping our future, subscribe to our channel now. Here you'll always find the latest news, in-depth analyses, and explanatory content presented in a clear and engaging way. Join us on this journey into the future. And until the next video.